Okay, so the other is the page number 3, which you have to be more focusing on, is that you are given like based on the result of admission testing. So do the boys and girls performs differently? So this table is not the same because you can see that you are not just boys and girls. Unlike the page 1, you are just given boys and girls, the number of boys and girls. But this part, it is testing about the sex and also the results about your test. What does it mean for do the boys and girls perform differently? So if perform the same, which means they are the ratio, which means boys, girls, their cleverness are the same, right? So however, if they are perform differently, which means maybe the girls clever than boys, or boys clever than girls. Okay, so we can test about whether the ratio of boys and girls have any effect with the test result. Okay, so the same is like we are using this one. This is the observed frequencies, which is given in the questions. Okay, we have 250 boys getting A, and then we have 350 girls getting A, 500 boys getting B, etc. Okay, so your first step is to add all the rows and then add all the columns to get the result. So say for example, how many people get the A? The 250 plus 350s, we've got 600. 500 plus 750s, you got 1250. And then this one plus this one, so you got the answers to be 800. Okay, so rows, you add all the sum of them, and then the boys, you do the same. So you will got the answers to be the page number 4. So in fact, you will get all the answers, which with boys 1098 boys, girls you got 1552, and then the total number of A, total number of B, total number of C's. So if there is no discrepancies, which means that if there is nothing difference between the performance of boys and girls, so you should expect, according to the ratio of boys and girls, 1098 divided by 2650, which means this number divided by, this is of course the total. So this is the fractions here is of course the boys ratio of boys. If I got the ratio of boys and there are a total of 600 people who got the A, so if there is no discrepancy, so you will expect that you multiply by 600, you got 248.6, which you leave more decimal places, so probably up to the 4 decimal places will be better. Boys getting B, you still use the same, this number divided by the total, so multiply by the boys. Okay, total by boys 1250. Okay, so you got the expected numbers who got the B for the boys. Okay, so this numbers is also the boys ratios to get the C, so you multiply by 800. With the same result, so you have girls ratios, multiply by 600, and then you will got how many persons expected to get A for the girls, and then similarly for the B and also the C. So after you have pressed the calculator, so you will got all the 6 numbers, which is the expected frequency, right? So the step number 1 is the same, that is what I taught in the previous part. Step 1 is to set up X0, no difference between test result and the sex. H1 is there is a difference between test result and the sex. So what you need to do in the second step is to following this part to use the chi-square test statistics. 250 should be the observed frequency for the boys getting A, minus this one, which is the expected numbers who got the A. So for the boys, I mean, okay, so you need to minus OI minus EI, and then bracket square divided by EI. The next is, no, this is the boys who got the A. Okay, how about this one? So this one is the 500 boys, or is a fact getting the B. So minus the 517.9245, and then bracket square divided by the EI. So you will got the answers for boys, and then getting the B. Okay. So the next is here we've got the boys getting C, and then this one is the girls getting A. And then here is the girls getting the B, and then the girls getting the C. Okay, so by using the calculators, you got 2.47985, so which is the test statistics. But bear in mind that if this is a table, and then this is called the contingency table. I mean this example. Okay, this is a contingency table, and then we have boys and girls, which means that we have 2 columns, and we have ABC, so which means we have 3 columns as a 3 row. Okay, if we have more than 1 column, more than 1 row, so our degree of freedom should be using this one. Okay, remember this is more important. So we have A minus 1, B minus 1, which means A is the number of rows, and then the B is the number of column, so which I said in the notes. So finally, so the degree of freedom is that this should be 3 minus 1 times 2 minus 1. So the degree of freedom should be 2. Okay, and then while you take out your chi-square test statistics, degree of freedom is 2, and the level of significance is 5%. So you can see that 5% and degree of freedom is 2, it's 5.991. Okay, and then you can see the 5.991. Okay, so according to the diagram, so you have the chi-square test statistics. So as I said, null hypothesis is rejected in these cases. So while the null hypothesis is true with number very close to 0, the critical value you check should be here, 5.991, and then the number you calculate, 2.47, should be this one. Okay, so finally, do you reject or not? So of course should be no. Okay, so because the null hypothesis should be true. So at the end, the null hypothesis for the sex and the test result is not rejected at 5% level of significance. So if it is not rejected, we cannot say there is any difference between the performance of test result and the sex. Okay, so and then you can try yourself about the activities 1 to 5, because the answer has been attached already to you as well. So please try it.